Hey guys, ItGuyMichal here and welcome to another video of our channel. In this video I'm gonna show you basics of the Dockerfile, which allows you to create a new image. Now, if you are a fan of Docker programming, Python or everything with computers in general, please consider subscribing to this channel where I every week post at least one video about this topic. If you want to be updated every day, there is an Instagram profile called ItGuyMichal where you can find very helpful tips about operating system, technical stuff and computers in general, so please consider following these on Instagram. Now, without further ado, let's jump right to our video. Right now I'm in my demo folder of the Visual Studio Code and I want to create a new Dockerfile. The Dockerfile, I will call it it's a new file, Dockerfile. Now, Dockerfile serves as a set of instructions which are read by the Docker daemon to create a new image. You can create a Dockerfile from existing images. Now, the existing images are called the parent image, which will serve as a base image for your image. Now, this makes sense. You don't want to create the image from the start. Now, let's say we want to create a Ubuntu-based image. So in order to do this, you need to specify a parent image. You can specify a parent image with the instruction called from. So you put here from, and now you need to specify the name of the image. In order to find the name of the image, you go to the dockerhub and you put here Ubuntu. Now the most liked image is the Ubuntu official image, and if you click on it here you can see the name of the image. In most cases the name of the image is the same as the operating system, so for example the Debian, the CentOS and the stuff like this. So we will use the Ubuntu in this case. As you can see, I can use all these tags here listed in tags in the description, but I prefer the image 18.0.4 because of the stability. Let's go and specify the name of the image, so Ubuntu, and now the tag or the version of the image, 18.0. Now, when you will build this container and run it, you will get the expected results. Now, in the previous videos, I'll show you how to run and build in one step and run in another step. So, if you want to build and run in one step, you can do it by specifying docker build. And here, when you want to build from the Dockerfile, you need to be in the folder where the Dockerfile resides. Now, in my case, it's the demo folder. Now, if I want to build it from the Dockerfile, you need to do it by putting a dot here. So if I will run it like this, it will build the Dockerfile. But besides building the Dockerfile, so building the image, I want to specify also a tag or the name of the image, and I will call it Jupyter, because in this video I'm gonna show you how you can run an image for a Jupyter lab, because I'm a big fan of the Jupyter lab, as I already mentioned, and I think you already noticed based on my previous videos. So you can build the image like this, and when you will build the image, the Docker daemon will go through these instructions, and first it will look for the first instruction, and for each of these instructions it will create a layer. Well, this is a lie, not for each of the instructions, but for them also of these instructions. So as you can see, the first step was looking for a Ubuntu image which should reside locally. Because I have previously created some images using the Ubuntu image, the Docker daemon didn't have to download the image from the Docker hub. But if you didn't used the image before, it will take some time and you will see some progress there as you will download the image from the Docker hub. Now I have the image locally. I called it Jupyter, so the thing I can do is just docker run rm, because I want to delete it after it, ty, and the name of the image, which is Jupyter lab. I call it just Jupyter, whatever. Yeah. So as you can see, I was immediately redirected inside the bash or the shell of the image, because now I'm running as a root inside the image. So if I press ls, you will see the structure is the same as in the Ubuntu. Now this was a from command. Let's talk about something different. Let's say you want to transfer data inside the build image. So let's say you want to transfer there a whole folder. So in order to do this, the Dockerfile is operating inside a context. Now, every instructions inside here are operating inside the context. And the context, if you don't specify, is the location of the Dockerfile. So in this case, the context of the build of our image will be the folder demo. So everything which is inside the demo folder will be available for the build run of the Dockerfile. Now, what you can do is that you can transfer the data from inside this context into the image and then later in the container. In order to do this, you need to use a special instruction which is called add. So let's create here a new folder and let's call it an app, and inside the folder create a file which we call a test.txt, and inside the test I will write just the test, right? Gonna hit the save. And now if you want to transfer these, you can use the add instructions, which will then copy from destination to the source, from the source to the destination. And how you can specify it is you just say, now you just say app, which is a relative path to the folder inside the context, and you specify the location, which needs to be a full path inside the Dockerfile. Now when you will run this, Ctrl S, you can now, again, you need to rebuild and run the container, but you can do it in one run, like and you put here the run command after that. If you are looking for the commands, they are linked in the Git in the description below, so feel free to follow me on the GitHub. So let's run this. And as you can see, another layer was added to the Dockerfile, so to the image, and which was just adding the layer. Now, as you can see, I'm inside the root. I'm inside the container running as root. So if I press ls, you will see that the app is inside there. And if I go to cat and the app and the test, it's there, test without the new line. Fine. So let's just terminate the container by pressing Command D or Control D, depends on the operating system you're running the Docker inside there. So if you go to Docker PS, you can see that the container was terminated because I was running with the TTI. Now let's go next. Now Docker provides you something else, one more instruction, the copy instruction. Now the copy instruction is doing basically the same thing as add. So it goes to the source location and copies the target from the source location into the destination. Now what's the difference between add and copy? Now there are a few major differences, and one of them is that by using the add, you can copy a file from the URL, right? You don't need to copy it from your local machine. You can copy, for example, a tar file from outside of your computer, so from the URL directly inside your container. But this is discouraged. I don't recommend using add too often. Instead, always use copy if it's available and if it's possible. And there are some hacks how you can copy from, how you can use the tar file from the URL without using add, which I can mention in another videos. These are just basics. So let's go and show you how the copy works. So if I just comment the add command and I do exactly the same thing with the copy, like this, hit the save button, go back to the terminal and run again the build and run, you can see the second layer or the second instruction was replaced with the copy. And when you press ls and again cat app test, you will see that the test is there. Well, that was fine. That was very fast and amazing. Now, as you can see, something is happening strange. Whenever I go inside the container, so when I'm running the container, I'm placed inside the root directory of the container. And sometimes when you want to operate inside a Dockerfile with the files inside the image, you want to change the work directory. For this purpose, there is a command which is called WORKDIR, or instruction which is called WORKDIR, where you can specify the full path in the image or inside the container where you will operate all the other instructions next, or which will serve as a working directory for your Dockerfile, for your image, sorry. So now specify to app, and when you hit the save button and go back next to the terminal, please clear this and run it. You can see another layer was added, and if you go here, you are immediately presented inside the app instead of the root directory of the container. So how amazing, how simple is that? You can specify almost everything with these instructions, but now let's go to the fun part. Now let's say you want to install something inside your image. So in my case, I'm using the Ubuntu image without any Python installed. There is no Python. So if I go here and go like Python, as you can see, I'm still inside the container. I put here the Python version. I don't have any Python installed there. So how you can install the Python? So because this is a Ubuntu, you can install it with using registry or the apt-get formula. Now to use this, you need a special instruction which is called run. And many Ubuntu lovers out there already know that you need to run something like apt-get update and apt-get. Well, I cannot spell it. Apt-get upgrade, right? Yes. And then notice that I'm using a multi-line syntax here. Python 3 and then the Python pip, Python 3 pip. Now, this is the thing which you will do on your computer locally. But inside the Dockerfile, one thing is not recommended. Please don't use the upgrade option for your run commands. Now, the reason for this is quite simple. The way how the Dockerfile works is that when you will build this, everything will work. So for example, if I go here and press save, and now I will build this, you will see that this will take a couple of time, but after a short while, the Ubuntu will update the registries and also upgrade the registries, and after that it will add the Python 3 and Python and pip 3 pip inside your container. But when you will run it again, so you will close the container and run the build again, you will see that the same thing will happen. So the container and the layers inside there won't be cached. Now, the way how the container works is that the Docker daemon is caching the layers inside your container, so it doesn't have to always rerun the build process, right? And for example, now many of you can ask, okay, Michal, so why is not caching the upgrade option here? And the thing is, like, there are issues with this upgrade command, and the official Dockerfile documentation recommend not using the upgrade command for the official images. Instead, use the install command. And when you will use it in the syntax like this, I will terminate this by pressing the command Ctrl+C. So when you will use a syntax like this, the Docker daemon will cache the installation of the packages for your apt-get, and it won't run the installation if you don't change anything in your Dockerfile and run the build again, okay? So I will just show you. So if you run these, it will take some time until it will be installed. So please shortcut. So as you can see, everything was installed and I'm right now inside the container automatically. And if I go like Python 3 version, the Python 3 is there. And if I go like pip 3 version, the pip will be there. And the advantage of using installed instead of upgrade lies in this. So right now, if you just exit the container and run the build again, as you can see, the Docker will notice that you didn't change anything inside your Dockerfile, so it doesn't like rebuild the whole container and all the layers inside there. So there is one more important thing you need to know about the Dockerfile. By specifying these instructions with the bodies, you are specifying the layers inside your Docker image. And now the Docker daemon treats them as dependent. So what does it mean? If you change something in the layer above the run, it will always rebuild all the next layers after the layer which you updated. So for example, if you will put here something like, I don't know, copy something else, yes, so some other folder, so up to, the Docker daemon will notice the change in the layer, in the second layer, and it will update all the subsequent layers. So please order the layers inside your Dockerfile. Please try to chain the commands, the Ubuntu commands, for example, in the run, and don't split the commands like run apt-get update and then another run apt-get install. This is causing a lot of problems to the Docker daemon, and it will make your images bigger. More layers you have in your image, the more bigger is your image, and then it's sometimes complicated to build it, it takes time, and it's complicated to push it and get to your desired location, okay? So this was just the basic about run. Now, having these, you can do one thing. You can now run the Python as a default command. So what is now the default command? So if you go to here to the Ubuntu, and I chose the 18.04 image here, so if I click on it, you can see that here is the Dockerfile for the Ubuntu image which I chosen. So as you can see, there is a from scratch, so this means they are using a default image to build the Ubuntu image. And now at the end, you can see that they are running some things. Yes, there are a lot of comments, blah, blah, blah. But the most important part here is this CMD instruction. And these CMD instructions specify the default command, which will be triggered after you run the Docker run. So as you can see, when I was running these, I will now exit the container, clear the screen. As I was running this Docker run Jupyter, this command was executed right after the image was triggered. So that's the reason why I was immediately put inside, the container to the bash, because this is the default behavior. But you can override this default command inside your child container, so inside your child image, which I'm specifying right now, by putting here cmd. And here you need to put these brackets, and inside, as you can see here in the description, you put the executable. So I want to be transferred directly inside the Python 3, and you can put there the parameters if there are, but I don't use the parameters right now. So when I will just run it again, as you can see, the Docker daemon noticed that there is a change, but the change was on the 5th layer, so it didn't create another layer, and it didn't rebuild the previous layers, yes. And I was immediately transferred to the Python console. So I'm inside the Python console. So if I put 1 + 1, I get 2, right? So when you will quit the Python console right now, you will automatically quit the running container. How cool is that? So this is now some background of how the things work inside the Dockerfile. So now let's say we want to install the packages of the Python using the requirements file, right? So you go to the app and you here created a file which is called, let's say, piprec.txt, right? And here you specify that you want to install the Jupyter lab, right? You hit the save button, and now inside here, because I want to trigger it inside the container, I run here the pip3. You need to specify the pip3 here because you are using Python 3 and Ubuntu is using the Python pip3 alias for this purpose. So you go the pip3 install r piprec.txt. Save, going back to the terminal, clear the screen, and let's run the, you need to go outside of the Docker. And when you will run this, as you can see, something strange is happening. The Docker is reinstalling everything, and now this can be some counterintuitive in the first place, because what I said last time was when you change a layer after something, all the previous layers will be cached, right? But this is true. But we changed also this layer, the copy app. Why? Because what does the Docker daemon in case of copy layer, right? So it goes to this app and it computes the checksum of all the files inside the app folder. So what does it mean? When you add a new file here, the checksum of the folder will change. So what does it mean? This layer has changed. So there is a change in this layer and all the subsequent layers need to be updated. And for this purpose, the run apt-get update and apt-get installed is now being rebuilt again. And so by adding a new file here, we are also changing the layer copy. Now, hope this helped you and this make clear how the layers work. We will continue right after the installation of this. So right now everything was installed, as you can see, and I was immediately redirected to the Python interpreter. So we will quit the Python interpreter, go back to the Visual Studio Code, and we will comment this command to get back to the bash right after the running. Because I changed the layer after everything, no rebuild is necessary. So right now I'm inside the container, and when I go like pip3 list, you will see that all the libraries for the Jupyter Lab has been installed. So right now I can run our favorite Jupyter Lab command, right? But before doing that, let's stop for a moment and think about the things which I said in previous videos. So if I will run the Jupyter command, right, I will be redirected to the localhost 88888, right? So for this purpose, I need to open the ports. And from the previous videos, all of you know that we can open the ports in the run command by specifying the parameter p, right? So we will do something like, well, in this case, when I will run the Jupyter, I don't need a ty, because I will not go to the shell. So I want to run it in the background, and I want to specify something like p and 888 the 888 here, right? So specifying these ports is telling the Docker, okay, bridge the connection between the localhost in the Docker container to the localhost of my local machine. Now, in the Dockerfile, to notify like everyone that you are going to use this port outside, is a good practice to use an instruction which is called expose. So you put here the expose and the port number, which is going to be exposed to the outside world. Now this is not necessary. Out of the box is the port exposed to the network by specifying the P, but it's highly encouraged, and you will see it in all the other Docker files out there from the expert developers, right? So now by specifying the expose port, the only last thing which we need to specify is the command to be run in the background, now the Jupyter Lab executable, to be able to access the Jupyter Lab. Now, the only thing which we need to do right now is to run the Jupyter Lab from inside the image. Now, in order to do this, we need to override the cmd command here by specifying this command. Now, I had this copied in my clipboard. So we are saying that we want to run it in bash. Now, why am I putting there the bash? The reason for this is that out of the box, the cmd is set to shell script. And running it as a shell, the Jupyter Lab command will trigger an error which will say that Jupyter Lab cannot be found in the path variable. So a good practice here is to put here the bin bash, and now I'm specifying the arguments for the bin bash. Where am I saying I want to run the Jupyter Lab command without all traditional setup, specifying the IP address port, no browser option, and allow root. By specifying this and going to the terminal, if I run docker build Jupyter and run rm and specifying the ports, where I'm mapping the port 888 to the 888, and if I run this, as you can see, I successfully triggered the Jupyter out of the box from the Jupyter image. Now, if we go here to the browser and go to localhost.888, you can see that I'm greeted with the welcome screen of the Jupyter Lab. Now, this is amazing. The last thing which I want to show you in this video is how you can publish your image to the community, how you can put it to the Docker Hub. So first of all, you need to go to the Docker Hub and create here an account. Please sync up with your normal, Gmail or stuff like this, fill up the password, complete the registration steps, and after finishing this, you can log to the Docker Hub account from inside your Docker. So if you go to the Docker command line, please stop this, and run docker login, you will be prompted to put in the username and password which you specified for the Docker Hub. By finishing this, you will be greeted with a message like, login succeed, and now you can push your images inside the Docker Hub. Now, how you can do that? If you look at the command which I was building the Jupyter image, I was specifying here the T as the name of the build image to the Jupyter. So right now you need to create your own tag for the image. And when I'm talking about the tags, you remember I was specifying the tag for the Ubuntu, it was 18.0.4. You are going to create something like this for your image. So you need to run the tag command by specifying the name of the image, which is Jupyter, and the name in the repository. Now, the name in the repository is specified like this. So you go to your Dockerhub account and you put here, and you click here on the create repository option. You put here the name of the repository, so in this case it will be Jupyter Lab. You create this as a public. Here are also like, how can you do this? This is the tag option and then just the push. So I can show you this. You don't need to specify anything else. You just click on the create. This will create the repository for you, and now you can push it here. So you need to specify the tag to the repository like this, and here you specify the version after the dots. Now by specifying this, you will have the thing in your images, the image with the tag in your images. So if you go like docker image ls, you will see that here is the Misoho Jupyter Lab with the tag 1.0, and now you can easily push it to your Docker hub by running docker push and the name of the tag. This will take some time. It will just slowly push the layers one by one. It's depending on your network speed. Mine is quite fast. So as you can see, I'm trying to move about 410 megabytes straight into the Docker hub, and then it will be available for the developers out there. You can create the private images and then just share the links and the passwords to those guys who are interested in. But I highly recommend like giving the community something which you created, and it's a good practice to work like this. Now, why is the image so big? The reason for this is because we're running the Ubuntu 18.0.4. I was thinking to run something else like CentOS or stuff like this, but then I was like, well, maybe most of you are familiar with the Ubuntu mostly, so let's do it with the Ubuntu. If you are running CentOS, for example, then in this case there is no apt-get. I think there is something else, so make sure you are using the right repository commands. Now, after finishing this and downloading it to the Docker Hub, the image will be available for everyone. So if you are interested in the Jupyter Lab image, go to Misoho Docker Hub and download the image for you. You can give me a star or rate it. I think this is the most simplest image. You can create even smaller images out there with the Debian Slim base images or stuff like this. Okay, so right now it's pushed. It will just take a couple of seconds to finish the operation. As you can see that it's a success. So if I F5 here in the Docker Hub, you will see a new tag here greeting us that I created the 1.0, and here is the nice Linux Ubuntu logo. So guys, this is everything for today's tutorial. I hope you learned something new about Docker files. These were just the base commands. There are a couple of others of them, like specifying the environment variables, the arguments, and stuff like this. If you are interested in information like this, please leave a comment and like. I really need your support. It helps me to, create this amazing content for you. And thank you very much for your amazing support. I got about 200 subscribers already, so I'm really glad that I have a community like this. I hope I will see you in the next video. Have a nice day. My name is ItGuyMichal.